After reaching a drag resistance, you have to overcome the resistance. Once you go to 30,000, the air density reduces. So amount of fuel need to be burned by engine to travel particular distance will be less. That's why most of commercial aircraft, passenger aircraft, or cargo aircraft, big aircraft, what you see in main airport, right? They fly around 35,000 to 40,000, 30 to 35,000 feet. But all the plane cannot travel in the same height, correct? One plane is traveling like this, correct? Maybe 35,000. Another plane may be there. This is a, for example, 737, small plane, 2,200 people it can take. It is going from Chennai airport, correct? This is Chennai airport, it is flying. It is start climbing. It is going and it has to maintain. Another aircraft, bigger aircraft going to, for example, Dubai 380, A380, big aircraft. It can take up to 800 passengers. Very big aircraft, correct? So biggest aircraft, commercial only A380, which can take up to this one. Even 747 is only 400%. Boeing, which was developed by 50 years before, and then they stopped the production last year. No more they are making new 747. Instead of they are saying cost is lesser than the 747, but Airbus is making 380. They also stopped. They made only some 250 aircraft. Because after that they stopped because they are not able to sell it. That is not our this one. This aircraft is coming, correct? This aircraft also take off from Chennai airport. Okay, and it has to go this one. So it may be assigned, maybe slightly higher, this one, 38,000 height. Because ATC person will tell to the pilot, first climb, take off and climb to 38,000 feet. And they maintain the height, same height. This we are talking vertical height from Earth's surface. This is 35,000, correct? So this pilot has to maintain A380, climb and maintain this one. Yeah, I say 737 Boeing. This is going to Dubai, and this aircraft can go maybe 800 miles per hour or 780 miles per hour. Right? We are talking less than also. This may be going 600 miles per hour or 500 miles per hour. I'm just giving approximate. Generally 540 to 800, because all commercial aircrafts are subsonic. The speed is subsonic, means less than the sound speed. 1 Mach is called sound speed. It varies depending on height and air density, that we know that. But so small aircraft may go around 500 miles. For example, easy for understanding, for 500 miles, correct? So because this is going to Chennai to Bombay only 2 hours, but Dubai is far away, 2,000 miles or something. So this aircraft 380 may go 600 or 650 miles or 700 miles. So if it is allowed to maintain same height, it may go and collide with the Boeing 737. That's why they separate aircrafts by some height. Generally 2,000 feet, something like that. Minimum 2,000 to 3,000 feet height, separation height they call it. This is 35,000, other one 38,000. Like that, different aircrafts, but at a time only few aircrafts. Now the maintained height while the cruising from the Chennai airport, the plane took up, right? It reaches 35,000 feet, maybe within 5 minutes or something, very slowly, 10 minutes it will climb and reaches. Then after that, maintaining same height till it goes near Bombay airport. Before reaching aircraft, pilot you would have heard a pilot, we have said near the Bombay airport, please put your seat belts, we are going to land, correct? So that means again height is reduced and the runway going to land on it, correct? So during this piece, it is controlled by pilot manually, correct? Engine, throttle, and the engine throttle controlling the rudder, controlling the control surfaces, ailerons, rudder, all these things. These are control surfaces. This is done by the pilot. But once during cruising, because you are not going to see like a road, correct? So when you are driving, now we are trying to drive car in the highway, separated, each car is separated by 10 meter, 20 meter. That is what autonomous vehicle, all those things are self-driving cars. But here, only thing is here speed is very low, correct? 50 kilometers, 70 kilometers, 100 kilometers, something. Aircrafts are going something around 800 kilometers, 700 kilometers, or miles, 500 miles, correct? So now the maintaining constant altitude doesn't require continuous attention of pilot. He can relax a little bit. That time the autopilot is nothing but in a small computer in which the Boeing company or Airbus company has made a software. It has an ECU, electronic control unit, in which software algorithms are written and stored, and engine All the fuel quantity, all the thing measured using a lot of sensor. Height is measured. There are a lot of sensor which measures. The parameter need to be controlled. Using that, the ECU control the engine, correct, and the rudder and all this thing, and maintain the required altitude and position. Altitude, correct. That is done by autopilot. So again, we say that it is electronically controlled. Okay, example for mechatronics. Then washing machine, you know that we have the washing machine, we will see that. Then automatic coffee vending machine, we are going to see in detail. So I'll just skip. You can see the lot of sensors, actuator, all these things are there. Mechatronics is there everywhere. As I told you, wherever you see. You go to this one, this is a humanoid robot. Asimo. Right? Developed Honda Corporation. Honda make car, also they make robots. Right? Honda Corporation, Japan, made a humanoid robot, which is called Asimo. Please note that they are doing this for the last 20-25 years, developing this humanoid robot. This robot can dance, walk, do all these things. The main purpose is not for that. They are trying to replace human workers with a humanoid robot. It has, you can say that it has exactly like a human finger, hand, all those things. So it can work tirelessly. Human operator, after a few hours, you go to your company, after a few hours, you get tired. Correct? Nothing wrong in it. Even I come to office by 8 o'clock, my 12 o'clock get hungry, I am teaching class, I lose energy. That's why there's a break. For your company also, you go and eat food, relax for 1 hour, come back and start working. By evening, again, you will become tired, all those things. By the time 8 or 4:30, you go. That is a human, no other option. All living things, when they start working, they lose energy, they become tired. When you are tired, you make mistakes. Correct? If in a production line, you may have to assemble some component, you may wrong assemble, you may not tighten some bolts, some nuts. If you are design engineer, you may make some small mistake which is not noticed. Finally, when product comes out, this happens. Correct? The major drawback, human. Correct? But to avoid that, they wanted to use the robots. If a robot looks like a human, it is called humanoid robot. Humanoid robot. It will look exactly similar to human. It has a head, it has a body, it has legs, it has hands, fingers, everything. But it is a mechanical system. Humanoid robot is made with mechanical system, links and joints. Any robot is made with this. Then it has a mechanical. Hello.
Hello, sir. Am I audible, sir?
Yeah, tell me.
Sir, I have one question.
Yeah.
I understand the purpose for robots, but for years I have not been able to comprehend why we need something that looks like a human. Because if we can make a machine that can replace specific tasks, which is kind of the objective, right? Why make something that is like a human?
Yeah. Okay. Fantastic question. Nice question. I teach another course for last 10 to 15 years called robotics and application. I'm teaching more than 10 different courses in IIT Madras for the last 20 years. Other one is robotic and mechatronics. This is called a bio-inspired robotic. Right? So robot looks like a living organism. It may look like a snake robotics. It may look like a humanoid robot. It may look like a bird, correct? And it may look like a dolphin. It may look like a four-legged horse, correct? All this human. Main thing is the energy efficiency of the human or living organism for the given weight and is very high compared to what machines we have made for last 1,000 years, 2,000 years, including modern aircraft, all these things. Correct? So main problem is energy efficiency, consuming less energy but still doing more work is called energy efficiency. Nature has through evaluation, humans are living organisms, any insect. For example, you talk about dragonfly. Have you know about dragonfly? Have you seen, noticed?
It looks a lot like.
Yeah, if you go to a forest some area, 10 to 15 grams only is weight. I'm talking about grams. Correct? It is insects. With this one, it has 4 wings. All this thing with all this front, all this thing. I'm just saying approximately. This can lift up to 100 to 150 grams or even 200 grams. Lift and fly. It can lift. This weight only 10 to 15. It can this one. Even now we have helicopter because the dragonfly can. It is sitting on a, for example, tree top. Correct? It can take off vertically. It can go in reverse. It can go forward. Any direction it can change. Even now, we are not able to make a helicopter after 100 years or 200 years research. We are not able to make a helicopter. Helicopter weight, we say payload. Correct? This is nothing but payload. The dragonfly can take an object which is 10 times of his own weight, payload. 10 times, but helicopter may weighing around 10 ton. At the most, it can pick only 8 to 5 ton, 5 to 10 ton or 8 ton, lesser than this one. We are not able to make because the dragonfly wings are propelled, wings are flapping by using muscles in the body of the insect. The muscles are so energy efficient, correct? They can produce more force or torque required to flap the wings compared to our jet engine in this one. That's one thing. Now that you ask why humanoid shape, for example, now I was driving my car, correct? I was driving my car to my office. Okay, I climbed. I am in the first floor. From first floor, I open door using my hands. Correct? Hands has a highly dexterous mechanism. I can grab a small needle and I can take a egg very correct without breaking. Or I take a spanner with a high grip. I can tighten. I give so much torque, tighten a big bolt. All these things I'm doing with the same hand. Correct? So I can control the force needed by controlling muscles. When tightening, when I taking delicate egg, I gently take, and when I want to break, I break it with a knife. Okay, that's one thing. Now, I just climbed from my first floor. I climbed down in the steps. After that, I went into a car, walked in the floor. Inside the car, I sat. I was driving the car. Again, came to my this one. I came to the second floor to my office. I can climb. I can walk. I can run. I can climb trees. I can swim. Correct? So, do you have a machine which can do all these things? I can climb tree. Single machine, have you seen anywhere in the world? Even America, Japan, robot, nowhere. Correct? So, and the human body shape is evolved from monkeys. We know the Darwin's theory. Correct? When we talk about religious people, they say God made. We don't know about that. But we know that complete proof, evidence from how the human body arrived from this. They have skeleton of 1 lakh, 2 lakh year, 3 lakh year before monkey. Correct? That monkey, how it become a humanoid. Instead of walking 4 legs, we are biped. Correct? With 2 legs, we are able to walk. Remaining 2 legs become hands. So with that, we are doing the work. So one of the most efficient machine in the nature is human. Nothing can replace. Even now, there's no machine which can replace human. Similarly, human brain can think. It can create music. It can create paint, create art. It can paint. It can make machines. It can design machine. I can with my hands. I can hit somebody. I can gently touch him. All these things are possible. This is correct. The mechanical structure, which is a humanoid structure, can walk, climb, swim, all these things. That is why they are trying to, Fukushima accident. Any idea?
It happened in Japan, 2011.
2011 earthquake, and the water went inside the reactor, and there's one reactor blown up. Lot of problem. Correct. First 28 hours, water was getting filled. Reactor stopped. Electrical motor, all this thing stopped because water went inside. Somebody has to go opening door and switching on something. All those things, but already radiation is because there's some crack. Because it happened. No human can go inside, but still, if you see there's a movie or documentary about that, some 5 or 10 Japanese engineer working in this one volunteered. They said few of them died because radiation, all this thing. They wanted to see that no further disaster happens, but they could not do. But later they said if the humanoid or this robot can, because that place is only accessed by humans, small manhole and go, and you have to turn your wall. Correct? This is a wall. There's a lever. The lever should be turned, right? And push it. The lever should be pushed down, then you have to turn. It looks very simple. Every day you're opening a cupboard or machine or something, there'll be a button in this. correct? With your thumb, you will press it, and using remaining, you will hold this and down. This looks very simple for human. There's no robot right now available to do both. This robo, which they have developed for 20 years, 20 billions of dollars, even now it is not able to open. In fact, Japanese government asked the Honda car, will you or Asimo will do go inside, because there's a small hole manhole that should be as a lever, push button like this mechanism to go. They said not that 10, 12 years before, 14 years before. Why they are developing? Because of the ability of the human structure, living organism structure. As I told, dragonfly looks very simple. People, nobody matters. If I ask a 20, 34 student, maybe 10 students would have really saw it very closely. If you're in city, you would have never seen the dragonfly. Because I am coming village, we have agriculture. If I go, at least I see hundreds of thousands of the dragonfly flying in my field. Right, to catching the small mosquitoes, all that is the food for them. It is good for us. Correct? Any pesticides are there, that will be eaten by dragonfly. For it is a farmer's friend. Okay, okay, that means it can be humanoid shape or industrial robot. Correct? Please note the humanoid robot also, every part is made of mechanical links, joints, body, all those things. Then industrial robot, know that it's a links, joint, all those things. Similarly, this is a mobile robot. This is called as mobile robot. Correct? Mobile robot means a mobile base. Please see the same industrial robot. This is called end effector or a gripper. Correct? So here we have the gripper. Right? Trying to pick a engine block weighing around to 150 or 200 kg weight. Engine block is handled by KUKA robot. This robot, please say it is a furnace. They are already very hot, 400, 500 degree engine block. Human operator previously doing some 50 years before. Now you are using robot which will go and pick this object and put it in some other machine for doing some other milling or forging some operation. So this is an industrial robot example. So if same, this is called robotic. This is called serial manipulator. Correct? Serial manipulator. It has a lot of links and joint. Every joint is controlled by motor. Here is a motor. Here is a motor. Here is a motor. There are 6 motors in the robot. That will be controlled by a controller, ECU, electronic controller, robot controller, which will control the individual motors, and so that the end effector position is controlled. Correct? The object will be taken from here to move by controlling robot. So the same robot is fixed on the table so that it won't fall down. But if I take the robot to put in a moving platform, this is a vehicle. Correct? It is a moving platform. I put it, the robot can go anywhere and do the work. Correct? We call it a workspace. Robot working area is called workspace. If I put on a mobile platform, the workspace is infinite. Wherever the mobile base goes, in that area it can do work. Again, mobile base move, again do the work here. Like this, it can do. So you get, but if I put my industrial robot on a mobile base, for example, you can see about the crane. Correct? Crane has a mobile base. Correct? And the crane operator. So you have a bigger mobile base with wheels, and which this is my crane. Crane is nothing but a serial robot. Correct? There's a hook. I can attach anything. This can move. The operator sits here and controls this one. This is a robot which is on a mobile platform. So wherever you want to carry some item, it can go anywhere. And Chennai can work today, tomorrow go to Bangalore, tomorrow anywhere this crane can go and do the work. So the workspace of the robot is increased by putting on the mobile platform. This is mobile platform. This is my robot or crane. Correct? So that's what is shown here. Then this is a underwater vehicle. You say UWV. Correct? This is like a small submarine. This is nothing but a small submarine. This is controlled by remotely sitting in a ship, a bigger ship, and you launch this in the ocean, and you can do the investigation. Anything under the ocean surface, below the water, you can go and check. Put your camera, see, it can take photographs, and you do inspection, all this, and checking all this thing. So again, this is controlled. The whole thing is a mechanical system. There's a submarine made of parts. Correct? There's a propulsion system will be there. There's a wing structure. Correct? The body. All these things need to be controlled so that the motion X, Y, Z axis you can control in the water. 3 dimensions are this. So it is a mechatronic. Similarly, you know that this is a unmanned aerial vehicle. Correct? unmanned aerial vehicle UAV. I think this is a Predator. I don't know exact this one. American Army, Navy, Air Force is using this. In this, there absolutely no pilot. Unmanned, there's no pilot. Correct? So the one computer is there. This computer, this entire way, this one it has an engine. Correct? It has the control surface. Correct? Rudder, all those things. Similar to aircraft, only thing pilot. Only main is this only pilot is sitting comfortably in Pentagon in a AC room, and he is attacking enemies in the Afghanistan. This is Afghanistan, correct? They used it in year 2000 to find the terrorists and kill them by using missiles. Correct? They use what you call a Predator. Pilot is safe, but in regular fighter plane, F-16, F-20, whatever maybe, including Tejas, MiG, what we are using, you need a pilot, manually controlled. This is autonomously controlled. This is an example. Please note that the robot need not be in the humanoid shape. It can be humanoid shape, underwater robot, this is industrial robot, this is generally called, this is also robot. A machine which can do something on its own is called as robot. Correct? So these are the example for different types. These are all mechatronic products. Okay. Again, we see about mechatronics example is autonomously guided. We call AGVs in the airports or in the shop floor. In your big machine, you go to big automotive company. Maybe you may be also using. I don't know. For example, Tata Motors, car factory, or Mahindra in your factory, not in R&D center. Right? So for moving the items from one location, generally you have forklifter. Correct? Forklifter will be driven by a human driver. He should know that. These days, a AGV, this is also driving inside the factory in a predefined path. It has a lot of sensor to see where some person is coming in front of it. There's a sensor which measures this, and the vehicle will be stopped. Please note that there's no driver. Everything is done autonomously, like self-driving car. So this is also AGV is also example for mechatronic system. It has engine, it has a wheels, it has electric motor. Correct? The steering system, braking system, all these things are controlled by a computer. So it is a mechatronic system example. Then mechatronic means not necessarily it has to be there. It can be a robot for surgical robots, teleoperated surgical robots. This has become very popular. One of the most popular, one of these are GUs. This is GU's robot, right? It has 4 hands, and in 4 hands it can pick up different tools to do a surgery. Please note that in this, the surgeon, this person is a doctor, highly accomplished doctor, sitting in the New York in his hospital, and the patient is in Strasbourg, France, on the surgical table. This is person sitting laid down, and they have to do a major surgery. That experience available only with this doctor who is in New York. Generally, what happened? The doctor should fly from New York to Strasbourg. It takes 1 day travel, at least 10-hour travel after airport, all those things. You will do the surgery. Next day again you go back. How many? 1 surgery. Surgery may take 2 hours. A complex surgery 3 hours. But traveling 1 day, going back another 1 day, totally is there 48 hours. But your effective utilization only 2 hours. Remaining the time is wasted. Instead of that, now you have teleoperated surgery, GUs, surgical robot they call. The patient will be anywhere. There's a video camera also in top. There's a video camera. It takes picture. That picture you see. In the robot hand also, there's a very close-up view picture. There are multiple cameras. The doctor can see using his joystick, like a video game. He is controlling the individual arms. One is holding a knife, other one is holding some other tool for do surgery, other one is holding a needle. All this thing can be controlled by him remotely. Within 2-3 hours, just like, because you're going to do surgery just like as if you're doing in person, but he is doing from far away. So after 3 hours, the doctor is free, can go on other patients. Correct? So this is again, surgical robot is made of mechanical links, joints, correct? All these things. So it is a mechanical structure. Okay. As I told, autonomous car, self-driving car. Correct? So it has a lidar, it has a camera, it has a radar here. Using that, it is seeing the road. Please see that this driver, this is a test vehicle. Correct? The vehicle has to go in this path. You can see the cones are put as if you are getting a driving license. So please see that this is the autonomous controller car video terminal. This person wanted to show you that I am not driving, I am reading newspaper, but the vehicle will go exactly following the path without making example. So another example is in some 1997, correct? Berkeley University in California with GM Ford, they are Toyota, they developed what you call the automated highway system, AHS, correct? In which this is a regular road, this is a special road in which there are magnets buried under the roads, and that is used for guiding this vehicle. This is all the vehicles are driven by a computer. They follow equal distance, they call inter-vehicle space, and same, if this vehicle going 60 miles per hour, all vehicle go. If the vehicle apply brake, all the vehicle apply brake. So they call platoon. Main advantage is no accident with the computer control, highly efficient. All this thing when we come to talk about autonomous vehicle, that time you will understand. But of course, 2023, they know what I am talking. Everything already they have done the course. It has a lot of sensors, correct? LIDAR, camera, radar, correct? Wheel speed sensor. All these things are used for controlling engine, brake, and steering system, just like human driver, so that the car is driven by computer, not by driver, without making any accident, which is called a self-driving or autonomous intelligent car. Okay. Now let us see what the important parts of the individual. This one example is a few example. We'll see about industrial robot. Correct? How it works? What are the components it requires? Correct? Motors, joint, links, how the control all those things. Then we'll talk about the automatic digital camera. What is internal structure? What are sensors? What are motors? How automatically adjust the focusing? All those things. All those things we'll talk about it. Another example, detail this one. Computer hard disk also, again mechatronic system. We'll talk what are the different components, correct, and how it works. Advantage. Then we talk about washing machine. Washing machine. This is the cut section view. What are the important mechanical parts and how it is controlled. There's a ECU, electronic control unit. There are amplifiers, signal filter, all those things. It has a lot of sensors, 4 different sensors. It can vary 5, 6 or depending on model you are purchasing. Automatic washing machine, and it has actuator. In any mechatronic system, you will have a mechanical system. This is a mechanical system. That's what this. Inside this is the drum. Correct? This drum should be rotated. This drum should be rotated clockwise, anti-clockwise during washing time, and to drying time it will be spun at 800 or something like that. So this mechanical system is controlled by this electronic system. Correct? This is the ECU hardware, the signal conditioner. These are actuators. This one, there's a control program. Correct? Control program inside. They're going to control. We will see about that. Then we also see satellite altitude control. You know the satellites used for communication purpose, cell phone, TV, all those things. They are all to maintain. What it is. Examples we'll talk about it. Finally, we will talk about IC engine. Already I talked about how the IC engine control also is a mechatronic system. That example we are going to see. Then we'll go to detailed this one. Tomorrow we are going to see another 1 or 2 classes. We'll see these parts. After that, we'll jump into more about what is embedded control, what is this, all these things. I'll stop here. See you tomorrow. Give your attendance as a chat message. Any questions? Any doubts?
Sir, just one question, sir.
Yeah, please.
Printer will be part of electronics or mechatronics?
It is a mechatronics. See, printer is a mechanical. No, printed all the movement. There's a this one carriage. The body is there. Mechanical. Without that printer, where is the printer? Is a mechanical, but it has one CPU inside printer. There's a controller that is connected to your computer through a wire. Computer sends the data to the controller inside the printer. The electronic circuit, there's a microprocessor, there's a small computer inside. Then you have motors which moves the printed, correct? And a very complex mechanical machine, one of the complex mechanical machine. Laser printer also is a mechanical. See, wherever see your mechanical parts, body, shape, this one, links, joints, all the things assembled together, then it is a mechanical system. If you control electronically, it becomes mechatronic with computer. Every product are built in the what you call ECU, which receives command from another computer or from the program what your front panel control you're pressing. Washing machine, you want to wash a cloth means you give command. What type of cloth it is, how long it should do washing, whether with water heated, all this thing you program before starting washing machine. You put the cloth inside the washing machine, then you select how much water should be used, how much detergent used, or you can select what type of cloth, then you say warm washing or cold water washing. You select it, then you say press start button, start washing. You go and relax and look into your TV, relax. 40 minutes, the machine does all the things because there's a control for all those things which executes all the washing, drying, rinsing cycle. Finally, whenever it gives a beep sound, you go and pick the cloth and dry it up. So it is a mechatronic system. Okay. So see you tomorrow. Give your chat message before leaving.
Sir, one last question.
Yeah.
These humanoid robots, like you know about these ASIL levels and all the regulations that we have, right? These humanoid robots are also bound by similar regulations, or are they all relevant for what field they are addressing?
No, depends upon where it is applied. It should conform to that regulations.
Okay.
Correct. For each application, there's a separate regulatory body. As per the regulation, this robot should be able to work. Then only that robot can use that application.
Okay.
No, the whole idea is humanoid is, see, for example, when the engineer is there, correct? He is a mechanical engineer. You joined, for example, which company you are?
Sir, Continental, sir, brakes.
Brake system. You are trained, you study mechanical, all this thing you know, but you are working on a brake system, all the relevant work. Instead of that, you joined your company which make washing machine. They are also in mechanical. Then you will be doing what is required for making washing machine, not what is needed for making the brake system. Correct? So for that, they check whether you have knowledge, whether capacity, all those things. Similarly, the humanoid robot can be applied to anything as long as the machine is able to do that. It is programmed to do that. It cannot do another. You have to, now we are trying to include artificial intelligence so that it can do that. It like a human without asking much question. Learn itself and do. Basic training you do. After that you learn in your company. Correct? That's what the AI we are trying to implement in the humanoid robots. All machines. Deep learning, all these things. Yes, please.
Professor, sir, can you share us the syllabus?
Okay. Next class I'll show the syllabus. Okay. See you.
Thank you, sir.
Thank you. See you tomorrow.
Thank you.
By 5 o'clock. Leave now.
Thank you, sir.
Thank you, sir.
Thank you, Professor, sir.
Thank you.
Thank you, sir. Thank you.
Yeah.